All right, it's noon on Wednesday, and welcome to this week's Iowa Learning Farms Conservation webinar. I'm Matt Helmers with Iowa State University and the Iowa Nutrient Research Center, and excited to be back this week to help to moderate the webinar. And this week we have Michael Killewald. He's an agrivoltaics outreach coordinator at Iowa State University. And he's going to talk to us today about overview of agrivoltaics, the integration of solar and agricultural production. This is a topic that I'm excited to learn more about because certainly get some questions about it and hear people talk about it a little bit. So as always, if you have questions or comments, please type those in the chat box and we'll get those to Michael at the end of the talk. With that, Michael, the virtual floor is all yours.
Thank you, Matt. So before I jump into agrivoltaics, I'd just like to give a little bit of a background about myself. So I grew up in Michigan on a small farm, and as soon as I graduated high school, I went over to Michigan State University to start a degree program in fisheries and wildlife. I was always interested in conservation and just like agriculture in general, so I always thought that I would work with like game species or like large mammals in some capacity. During my studies, I became interested in insects and started working in a small fruit entomology lab, and eventually decided to go on for graduate school and pursue my PhD in entomology at the University of Manitoba. So up in Canada, I was studying the use of these floral enhancements alongside of the rotational field crops that they would grow up there to try to see if these floral enhancements could increase beneficial insects and decrease the pests that would attack the crops. During my studies, I learned a lot about insects and also a lot about the things that drive their populations. So most of my studies so far are focused on bees and other wild pollinators. And most of the reason why their populations are in decline are due to pesticide exposure, limited floral resource, and pathogens. But generally speaking, it's not any one of these that acts sole. It's a lot of these will interact together and cause what some people call this death by a thousand cuts. So there's a whole bunch of small interactions that together will add up to be a large effect for insect populations. This is problematic because, at least here in North America, we're seeing a 30-year decline, at least in honey production and beekeeping. So if you take a look at all of the yellow on the bottom, you can see that the number of colonies in the United States is roughly consistent from, the 1990s up until the early 2020s, but the amount of honey that's produced per colony has been steadily declining over the years. Some research that's come out in the last few years has been looking at the use of solar facilities and if you can restore sort of like prairie remnants underneath them to conserve pollinators and other beneficial insects, basically building off of the work that I was already doing up in Canada. But instead of installing these floral resources along the edges of field crops, you would now be installing them underneath of solar panels. So once I graduated with my PhD, I, in a way, sort of came somewhat full circle. So I started off in Michigan, going for like insect conservation, moved up to Manitoba to study insect conservation and agriculture. And now I'm moving back to Iowa so I can study the integration of solar panels, insect conservation, and agricultural production. It's not just me that works on this project. This project was started a few years before I started here. So I have been part of Iowa State University for about a year and a half now. This was originally a project that was funded through the Department of Energy, and I believe that it started in 2024. So the project overall is titled Leveraging a Public-Private Partnership to Address Technical and Socioeconomic Factors of an Agrivoltaic System. So as part of this project, we have established a solar farm on Iowa State University's property that we are using as a research and demonstration farm to test all of the different possibilities about agrivoltaics here in Iowa as well as the Midwest. So a lot of the collaborators on the project, like Ajay Nair and Suzanne Slack, focus on horticultural crops or crop production underneath the panels. Matt O'Neill focuses on the entomology, like the beekeeping and the pests that are associated with the different areas. There's Hung Lee Feng and John Tyndall that are focused on the economics and sociology of, agrivoltaics and public perception. We also have Ann Kimber, Hugo Villegas, and Liang Dong that are focusing on the power production side of things. So how much power is produced at the solar farm, and does vegetation management influence the power that's produced? And of course, there's a lot of questions regarding this because the use of solar farms is sort of a relatively new concept. So I was hired on as the outreach coordinator to help facilitate tours of the solar farm, as well as answer questions and sort of teach people about the use of agrivoltaics. I started on this project in February of 2025, and ever since I've led dozens and dozens of tours of the solar farm, as well as different outreach events to try to teach people about agrivoltaics. So, as part of the tours, people will get to see the Alliant Energy Solar Farm at Iowa State University, and I'll give sort of a broad overview of all of the different research projects that are currently going on here. Just to give a quick overview of the site, this is an aerial image of the Alliant Energy Solar Farm at Iowa State University. If you're familiar with campus, this is located just about 10 minutes south of campus. It's right next to the ISU dairy farm and directly across the street from the Ag 450 farm. We have about 10 acres that are under solar production, and this total equates to about 1.3 megawatts, which is enough to power about 200 homes. Because this is a research and demonstration farm, we have two different types of solar panels that are located here. So the west side of the farm is the single axis tracking, where the solar panels will tilt to follow the sun throughout the day. And the eastern part of the solar farm is all this fixed tilt system, where the panels are bolted into place and they do not move. Now, jumping into agrivoltaics, at least the agricultural aspect of this can include multiple different things. So traditionally, the agricultural part of agrivoltaics is either livestock grazing, crop production, or beekeeping. Because we only have one solar farm on campus so far, and this is only about 10 acres, we've decided to focus on beekeeping and crop production because these were the two methods that we thought could coexist. Because, of course, if you have livestock out there, they're going to eat all of the crops and most of the flowers that the pollinators will visit. So I primarily work in the O'Neill lab, and because of this, one of the main projects that we've been focusing on is taking a look at the honeybees that can be placed at solar farms. So Carl Bowling, which is shown here, is a master's student that works in Matt's lab, and he's been focusing on the use of honeybees for honey production at various solar farms across Iowa. So he has 3 different solar farms that he visits. One of these is sort of a typical solar farm that you'll see on the left, where they manage the vegetation by mowing the grass every single month. The second solar farm is located over by, it's on Airport Road over by Sam's Club here in Ames, and this is the SunSmart that's owned by the city of Ames, and it's grazed by livestock. So they have sheep that they will rotate throughout the solar farm during the summer. And last is our solar farm, so the Alliant Energy Solar Farm at ISU, and this is where we're practicing horticulture and conservation for insects. So when Carl takes a look at all of the honey that's produced from all 3 of these solar farms in both 2024 and 2025, what we notice is that across the board, at least in 2024, honey production is more or less the same. We didn't notice any statistical differences in the amount of honey that each colony would produce. But when we look at 2025, we notice that there's this drastic increase in honey production, specifically at our solar farm. And you can see here in the background, these are the colonies that were placed at our solar farm. And if you notice, there's a whole bunch of white clover that's blooming in the background. So I think a big reason why we saw such an increase in honey production, at least at our site specifically, is because the grass and clover mix was planted across the entire site. And we saw about a 10-fold increase in the number of flowers between 2024 and 2025. So this here is a floral assessment that Carl did in both years, and note that the x-axis here is on a logarithmic scale. So we're noticing about a 10-fold increase in the number of flowers that are in these pollinator and grass mixes between 24 and 25. So if you noticed on the last slide, there were 3 different mixes. So there was the grass and clover, which is sort of this industry standard that would be found at most solar farms across Iowa. But we're also trying to establish sort of a remnant prairie or some sort of a seed mix that has a bunch of native floral species in it that would be beneficial for insects. The insects that I described at the beginning that are typically in decline from various reasons, but one of the bigger ones being a lack of floral resources. So if we can add more floral resources back into the landscape, this could benefit insects and also increase pollination services of the horticultural crops that we have on the farm. We have 3 different mixes, but the pollinator mix is basically the same floral species composition. It's just managed in 2 different ways. So typically speaking, a solar farm would go out and they would mow the vegetation once a month. So we are testing both monthly mowing as well as treating it more like a prairie reconstruction, like the picture that you can see here on the right. One of the biggest costs to operating and managing a solar farm after it's produced is vegetation management. So if we can establish some sort of a prairie remnant that would both attract pollinators, conserve insects, as well as reduce the amount of mowing that would be needed at the solar farm, that's a win-win. So I mentioned earlier that the agricultural part of agrivoltaics typically means grazing, beekeeping, or crop production, and that we're choosing to focus on beekeeping and crop production at our solar farm. So at least at the Alliant Energy Solar Farm at Iowa State University, we've been prioritizing commercial scale production of various horticultural crops. And this means that we're using standard equipment, so a 65 horsepower tractor with standard 3-point implements, both inside as well as outside of the solar panels. So you can see in this picture here where we're growing broccoli between the panels, we use a 3-point attachment behind the tractor that will both kill, lay down drip line irrigation, install plastic mulch, and then they'll also come behind and install this weed fabric. What we notice when we compare the various crops that we're growing both inside and outside of the panels is that some of the crops seem to respond positively to the panels, while some crops do not. So, for example, if you take a look at raspberries, if you notice where you normally find them out in the wild, they're always in the understory or in sort of shady spots of like forums. So it sort of makes sense that they would love the additional shade that the solar panels provide. And when we take a look at the yield, we see that there's an increase in the weight of raspberries that are collected from the plants grown underneath the panels compared to out in the open. And this is rather consistent across the entire season. When we take a look at other crops that might not be grown directly under the panels, like summer squash here, for example, is actually grown between the solar panels. We see a similar effect where the yield, at least in terms of weight of summer squash, is vastly increased when you grow it between solar panels compared to a traditional open field setting. Now, this graph is a little bit messy, but if you take a look at the marketable here on the left, you'll see that there is also an increase in the yield of bell peppers that are grown between the solar panels as well. So although this isn't statistically significant, the trend is at least that there is about 250 more bell peppers that are grown in the same unit area underneath the solar panels. One of the other things that I find interesting, at least looking at the bell pepper data, is that you not only produce more fruit, but bell peppers are really susceptible to what's called sun scalding. So if you think of yourself, it's very hot out in the summer, it's really easy to get a sunburn. What happens with bell peppers is if they get a sunburn, it'll cause these little marks on the outside and it will cause the bell pepper to rot and become unmarketable. So the additional shade that comes from the solar panels actually reduces the sun scalding effect, increasing the number of marketable fruit that you get at the end of the season. So far at our solar farm, we've tested 5 different fruit and vegetable crops, and all of them have at least trended that there was an increase in yield when grown between the panels. However, the one crop that we have tested that has shown a decrease in yield has been the broccoli. So when you think of broccoli, it's typically planted very early in the spring, and you're eating the flower part of the plant. And at least what I noticed from going out and visually comparing these plants, the broccoli that was grown between the solar panels would tend to put more of its energy into the leaves and less of its energy into the flowers because it was trying to branch out and look for that additional sun. So this would be beneficial for some crops like leafy greens, but broccoli, for example, where you're eating the flower, might not be so, I guess, suitable for an agrivoltaic system. I've mentioned a couple times that, of course, these yield differences are due to the shade or the temperature. And this is one of the biggest things that we notice for the vegetables that are grown within the agrivoltaic systems is you can notice this really crisp and clear line of shade. And because these are single axis tracking panels, as the panels tilt throughout the day, that shade will actually move across the ground. So what we're noticing is that the microclimate not only varies between the open field and the solar farm, but we're also noticing that the microclimate will vary within the solar farm itself. So these rows on the west side will get more of that early sun, or at least earlier in the day, where the panels that are on the east side of the space between the solar panels will get more of that afternoon sun. And these are leafy greens, so cabbage and lettuce that are currently planted at the solar farm. When this picture was taken, these were only established for about a week, and we're already starting to see differences in the size of the cabbage that gets more of the early light versus the cabbage that gets more of the light later in the day. But like I said before, I'm an entomologist, study bees and other pests. So one of the things that we're also noticing is that this shade may also change pest pressure as well. So one of the things that we also noticed is that, at least the trend, is that there's less insect damage within the solar panels when you compare this to the open field. And though we're not exactly sure what insects were damaging the bell peppers, one of the things that was immediately obvious to us is that the Japanese beetle presence within the panels was a lot less than the Japanese beetle abundance out in the open field. So I decided to measure this last year. So Japanese beetles are a very common pest. They will attack a lot of different species, but they seem to have an affinity for various fruit crops. At our solar farm, we have grapes, raspberries, and strawberries that are both grown in the shade, so under the solar panels, as well as the full sun, so out in just a traditional like open field setting. When I would go around and look at each individual plant and count the number of beetles, I would see that there was a significantly higher abundance of Japanese beetles in the sun when compared to the shade underneath the solar panels. And when I would take a look at the amount of leaves that the Japanese beetles were eating, so how much were they consuming, there was also a trend that they would consume more of the leaves and more of the plant when that plant was grown out in the sun versus when it was grown under the shade of the solar panels. And these weren't just one-time trends, these were trends that we noticed across the entire season. So I sampled from July until September, and we consistently noticed more Japanese beetles in the sun, as well as more leaves that were consumed in the sun when compared to the shade. Now, this isn't an effect that's sort of new. So about 20 years ago, there was someone that studied the effects of shade cloth on roses. And what they found is that the feeding of Japanese beetles was based on stimuli that was at the leaf surface. So there was either a stimulant, something that would reinforce feeding, or a deterrent, something that would make them fly away and go and choose a different plant. And what they found is that the roses or the plants that were grown in full sun produced more foliar sugars, which meant that the Japanese beetles were more likely to eat the leaves of the plants in the full sun. So I guess sort of coming to, wrapping up the webinar, what does all of this mean for Iowa? So last year, Mid-American announced that they're wanting to generate 800 megawatts more power, specifically within solar here in Iowa. And about 7 to 10 acres of agricultural land is needed to make 1 megawatt of power. Within the state of Iowa, most right now, a lot of the zoning practices for agrivoltaics are up at the county level, where most counties do not actually acknowledge or define agrivoltaics. But this is something that is starting to change. So Linn County, for example, does define agrivoltaics as the simultaneous land use of energy production and agriculture. So the use of agrivoltaics might be a way to increase the land that is available for, say, horticultural crop production, where something that could be done on a slightly smaller scale, that could be a viable, I guess, use here in Iowa. Just before I wrap up, I would like to thank all the people that have sort of helped me and sort of worked together to create a lot of the data sets on this project. So Cecily, Anna were both undergrads that worked in my lab and helped me with the Japanese beetle research. Carl and Jared were both beekeepers that helped with the beekeeping data. Ray, JC, and Brooke are all horticultural students, and they were all working to produce the fruit and the vegetable crops of the solar farm. And again, just because my role is the outreach coordinator for the agrivoltaics project, I lead a series of open house tours of the solar farm. So if you sort of found anything today interesting, maybe you would like to view a solar farm, take a look at some of the crops that we're growing, go ahead and scan this QR code and you can sign up for a tour of the solar farm and you can come and see everything in person. I'll also be there to answer more questions. Generally, these tours last about an hour, hour and a half. And there's tours that are scheduled both on Friday evenings as well as Saturdays in the morning. So whatever fits your schedule best. And with that, that's about all the slides that I have. Thank you.
Michael, thank you so much. We've already gotten some questions in, and if folks still have questions, please get those in. I want to thank the partners that make the Iowa Learning Farms Conservation Webinar Series possible: the Iowa Department of Agriculture and Land Stewardship, the Iowa Department of Natural Resources, the Iowa Nutrient Research Center, and the Leopold Center for Sustainable Agriculture. So thank you to those key funding partners that make the Conservation Webinar Series a reality. Let's go to the next slide. If you watch this webinar live and are wanting to earn a CCA CEU, email Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today, including your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu. Next slide. If you watch this webinar live and are willing to fill out a voluntary survey, we greatly appreciate it. Only one survey response for this is needed for all 2026 webinars. You can go to that website, iowalearningfarms.org/survey, or you can scan the QR code. Again, only one survey response for this is needed for any 2026 webinar. And if you've done so, thanks again. If you're willing, we'd greatly appreciate it. Next slide. What do we have? Ooh. Okay, we got Rob Myers, that's the director for the Center for Regenerative Ag at the University of Missouri. He's going to be continuing our Beyond the Basics Advanced Cover Crop series, and he's going to talk about the top 10 ways that cover crops impact soil health. So please tune in next week to hear from Rob on cover crops. Okay, excuse me, Michael, next slide. Okay, if you watch this webinar live and want to go back and see anything, this will be archived and available on the Iowa Learning Farms site or on our YouTube channel for webinars. Or if you know somebody that could benefit from watching, please forward it to them, because the more people that watch it, the better. All right. I think that's it for slides, if I'm not mistaken, Michael.
You are correct.
Okay. So we got some questions here. I'll start with, and I think quite a few of them were answered as you went along. So there was definitely a lot of interest in you. They had questions that you ended up answering in future slides. But, and I know that most of your work has been done more on the bees or the horticulture side, but from on the agrivoltaics, um, has testing been done to see if there are any negative effects on the animals that graze under the solar panels?
So here at our solar farm, we're not choosing to
Yeah.
look at animals at the very least, but I do know of others that are looking into grazing, specifically cattle at least. So Brad
Okay.
Hines up at the University of Minnesota is taking a look at dairy production as well as like dairy cattle and how they respond to solar panels. And it seems like most of the responses are positive. So it
Okay.
reduces heat stress and increases milk production.
Okay.
I'm not exactly sure if anyone has looked into like beef production and if like
Okay.
there is, I guess, an increase in the weight of meat that they put on, per day or per week. But so far, I do not know of any negative effects on the animals
Okay.
themselves. Most of the time, people tend to worry about the negative effects of the animals on the solar panels, like
Yeah.
breaking them or something.
Okay, great. Um, one person indicated the prairie remnant is beautiful, which I would agree. Is there any concern about fire risk with that unmowed area, or would there be management considerations for that, maybe?
I think that there would be management considerations.
Yes.
So currently they're going out, when I say they, current practices are they tend to go out once a month and mow the vegetation that's under the panels. At
Okay.
least the goal of the prairie remnant, I guess, wouldn't be to completely eliminate mowing, but at least reduce it to the point that you're not going out every single month.
Okay.
So maybe they would go out once a year, every couple of years or so, and just maintain some of that thatch that's on the ground to reduce fire risk.
Okay. Here's a good one. Kind of thinking about, can you describe some of the mechanization differences between if we were growing these crops in an open field versus under the panel? How, pest control, um, dust from tillage might have to be managed.
So at least at our solar farm, in terms of planting, general horticultural stuff, they're managed exactly the same way underneath the panels as well as out in the open. So the row
Okay.
spacing, the way that we lay the rows, the varieties that we plant, whole 9 yards, it's all exactly the same. In terms of pest management, up until now, we have been treating both areas exactly the same. So if we notice pest pressure on one plant in a plot, we tend to spray all of the plots, at least of that same species. So like if we notice one pest on tomatoes, it's very likely that they'll be also in another area. But with the research that I've been doing lately and others, where we're noticing less pest pressure underneath the solar panels, we're actually going to change that this year to where we're only going to spray the plots that need it.
Okay.
And I'm kind of curious to see if that might end up being a reduction in sprays underneath the panels, because we've already noticed a reduction in the number of adults as well as the number of leaves that they defoliate under the panels when looking at Japanese beetles.
Um, we have one here, and I think, in some ways might fit in with what you just kind of were just talking about us. But how could agrivoltaic systems be integrated with precision ag technologies such as sensors, drones, and maybe AI-based decision support system?
So one of the things that I was talking with Jordan Mackinick about, he just came to visit Iowa State University, and he, I guess, is one of the innovators of agrivoltaic research. They're starting to look into the use of, if you imagine a Roomba, but basically a
Oh
Roomba that
yeah,
would mow grass,
yeah.
using these like AI or grass cutting robots within solar farms as a way to at least decrease that operation and maintenance cost of taking care of the vegetation.
Mhm.
So there are some people that are currently looking into like AI and like digital agriculture in terms of spraying pesticides only on, say, thistles instead of horticultural crops, using these robots to go out and mow certain areas or pre-mapped areas of the solar farm. That way you don't have to send people out there.
Mhm.
So the technology is evolving, I guess.
There's a question here that, again, may not be in your wheelhouse, but it's kind of interesting and might be something that leads to a future webinar. But somebody asked, does the original landowner retain rights to farm between the panels?
So it depends, but in our
Okay.
case, yes.
Okay.
So something that I didn't have the time to get into, and it's more of like a, I guess, a socioeconomic thing, is it takes a landowner, a solar developer, and like an electric company to make all of this work. So in our case, Iowa State University is the landowner, and we have developed a site access agreement in partnership with Alliant Energy that allows us to retain farming rights of the land that is not under solar production. So basically, we can farm underneath the panels and between the panels. We just can't change the structure of the panels themselves.
Okay.
So this was something that we worked out before the site was developed, and something that I always encourage people that are looking into solar developments on their own land to think about before they actually start building them.
We've had some, this is a little bit of an aside, but kind of related. We've had some discussions within the drainage community that there have been some drainage problems associated with some of the agrivoltaics. And so there's some folks working on that, trying to think about how we do that so that, the solar farm is not negatively impacted and the adjacent land is not negatively impacted.
Yep.
Um, when you looked at some of the increases in vegetable production, is this with the same fertilizer inputs?
Yes.
Yep.
So I believe that it's the same fertilizer inputs across the board. They do soil samples every single spring, and then they generally fertilize the plots as needed. So of
Yep.
course, there's going to be differences based on what was planted there, but I think, say, all of the tomato plots will likely take the same amount of fertilizer, both inside and outside the panels.
Okay. And has anybody looked at how the panels change rainfall patterns or soil moisture patterns kind of below the panels?
So that's a great question. It's not
Yes.
something that we have looked at specifically here at ISU. If
Okay.
you do look at the panels, and this is something that comes up during the tours, exactly where the panel, I guess, terminates, you can see where the water kind of runs off on that, and you can see just like a small little divot, I guess, in the
Yep.
ground where that rain falls exactly right there. When I say small, maybe a half inch to an inch at most. You don't really notice it unless you're looking for it.
Yep.
So if anything, the panels might help to direct some of that water towards the crops that are grown between the panels, at least.
Okay. Has anybody ever looked at uh, engineering a capture system there for where those panels drop off and that we could do rainwater capture?
We've thought about that for our
Okay.
panels, but more or less it's stopped because our solar panels have a 12-year warranty. And if we attach anything to the solar panels, then it voids the warranty.
Okay. Okay.
So basically what I was told is maybe that's something that we can look into on year 13.
Okay. Okay. Get back in touch. I'm curious. Okay. Here's one. Do you plan to look at quantify any beneficial insect abundance in these areas?
So the short answer is yes.
Okay.
I'm already starting to monitor the insect community that's found within some of these plots of the solar farm. And my plan, at least, is to try to compare the beneficial insects and the pest insects between both inside and outside of the panel.
So here, just had it. Somebody indicated they'd recently heard of people worrying about fires in the battery packs of the solar installations. Have you heard any of that? I'm assuming it hasn't happened at the site at Iowa State, but.
So that is something that I have heard of and that I am aware of. Our site specifically does not have battery storage. So our site does not have that same fire risk.
Okay.
I do know that that is something that's coming up, at least in county regulations and for solar siting, that there can be differences on where you can place a solar farm depending on if it has a BESS system or not.
Yeah. Okay. I guess this is one like kind of like a question that would be for a graduate student that's defending. So I'll kind of feel bad about this one, but if you could change anything in your research process or data collection, what would it be?
Uh, I guess if I had unlimited time and resources and whole 9 yards, it would be nice to have more sites because right
Okay.
now, at least when we run statistics, I like to think of things from a landscape scale because my
Hmm.
graduate work, at least in my PhD, focused on where do you place these floral enhancements in the landscape. And when I think of this solar farm in the landscape scale, I have an N value of 1.
Yeah.
So it would be nice to be able to look at different solar farms in different landscapes and different contexts and see, do the insects respond the same way? Like, do Japanese beetles avoid the solar panel, avoid the shade of the solar panels only when it's in a heavily agricultural area? Or did they respond the same way if you have sort of trees and water and other natural like resources
Yeah.
nearby?
Next question is how close are the panels placed, or kind of how close are the rows?
So the spacing of the rows varies between the tracking and the fixed panels. And a majority of that is because the tracking panels, the rows run north to south, and the fixed panels, they all run east to west. So the tracking panels, I believe, are 18 or 20 feet from the leading edge to the leading edge. And the fixed panels, I think, are about 20 to 25 feet.
Okay.
So one of the first questions we had on the project, and one of the questions that I get, at least before people come out to the solar farm, is, well, can you fit a tractor in there or can you fit agricultural equipment? And I personally have backed up trailers between the solar panels. I run skid steers in and out of some of these plots between the panels to scrape mulch, clean everything up. And they even use, I think it's like a 125 horsepower tractor with I think it's a 15-foot batwing mower that they'll
Okay.
back up between some of the rows of panels.
And somebody asked the optimum ratio of photovoltaic area per acre.
So, at least if you're trying to maximize solar energy production,
Yeah.
you want to put the panels as close together as possible, but you don't want the panels to shade themselves. So, like as the sun moves throughout the day and, of course, throughout the season, you have to be able to space them far apart that one panel won't ever produce a shadow on the other. And that's where
Hmm.
that spacing sort of comes into effect.
Okay. Right. Yeah.
So, it changes based on location, but at least at our latitude, that tends to be about 20 to 25 feet apart, give or
Okay.
take.
This is I think that gets most of our questions. There was kind of a tile question about if it's with prairie, any chance of the roots plugging that tile? Could be a chance of that just from our drainage work, but not in all cases will the prairie plug the tile. We have some plots where it hasn't as well. So
Yep.
I think that's pretty much it. Michael, this is really interesting. I hope that as you get more information on this, you're willing to share with the Iowa Learning Farms webinar series again, because this is really interesting and super important work.
Thank you. And of course,
Yep. All right. Have a great day, everybody. If you need a CCA, CEU, please email Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today, including your name, the name you entered to watch the webinar, and your CCA number. And please tune in next week to the Iowa Learning Farms Conservation webinar. Everybody have a great day.